Hey friends, I am Ayali Bhattacharya and I'm 18 years old. I have just started my BSc Statistics journey. This is my first time trying anything like this and I honestly have no idea how it will go. But I do know one thing, I'm going to give it my heart. Alright? I'll be sharing everything I learned in my college classes, just like how I'd explain it to my own friends, which includes you. I might fumble, I might not be perfect, but if you're someone who's also trying to learn stats and needs a study buddy, I am right here. Let's figure this subject out together one video at a time. So, yeah, grab a notebook, maybe a cup of tea, and let's start with our first class. Now, here we'll start with the basics of probability from a simple topic. I'll also provide clear notes in case you don't understand the handwriting, and I'll also provide a few questions which I have already done in my class. Yes, so starting with the topic random experiment. There is nothing much to explain about random experiment because a random experiment is any activity or process that gives us one outcome and we can't say for sure what the outcome will be before doing it. Basically, a random answer, random outcome. Okay, we can give examples for this. Tossing a coin. Why is tossing a coin a random experiments example? Because you can understand we might get heads or tails. We can't say for sure which one. And another example can be rolling a die or picking a card from a deck, or choose a student at random, anything. So, summing it up, if you don't know the result in advance and you can repeat the process under the same conditions, it is a random experiment. Now, coming to the next topic, which is events. Now, let's talk about events. An event is any possible outcome or group of outcomes from a random experiment, right? Event can be two types. One is elementary event, and another is composite event. Elementary event is one outcome, and composite events means multiple outcomes. We can understand through examples. For example, we will take a very constant example, rolling a die. To understand our full class, we'll choose this as our constant example. So for here, one outcome we can choose getting a 3. This is one outcome. And for composite, we can take the example like getting an even number when the die is rolled, which is 2, 4, or 6. Yes. So for to sum up this concept, we'll use so events can be elementary or composite depending on how many outcomes are included. Now coming to the next topic, which is sample space. Sample space is a very elementary concept. It is denoted by S and it means the set of all possible outcomes of a random experiment. I'll only write the keywords. You'll get everything in definition and the examples in the notes section, okay? So yes. Now if we choose again the same example as I said, rolling a die, what should be all possible outcomes for it? It can be 1, 2, 3, 4, 5, and 6. All right, all possible outcomes. If we take another example, like tossing 2 coins, what can be the possible outcomes? It can be head and head, it can be head and tail, it can be tail and head, it can be tail and tail. So the number of outcomes in a sample space is again denoted by NS. Okay. Yes. Now coming to the next topic, equally likely events. What is equally likely events? It is actually a very important idea to understand. If every outcome in the sample space has the same chance of happening, they are equally likely. Same chance of happening. Right? We can take the example. We will take two examples to understand this concept. For example, if we toss a fair coin, then what are the chances we get heads or tails? Half and half, like 50-50 chance for both heads and tail. For the next topic, for the next example, we can take rolling a fair die. Mind my term, a fair coin, a fair die. This is very important, fair. Okay, for rolling a fair die, each of the 6 numbers has 1 by 6 chance, right? So again, this is an example for equally likely event. Now, summing up the concept, we'll say we assume equally likely only when the problem says it's a fair experiment, like a fair coin, fair dice, or random selection. Now coming to the next topic, which is favorable outcomes. What is favorable outcomes? When we solve problems in probability, we need to find out how many outcomes are favorable to our event, right? So basically, the things which we are interested in, right? Meaning how many outcomes match the condition we're looking for, interested or match the conditions, anything which you can say, anything you can say, right? Yeah. So for example, we'll take if E is the event, we'll choose E as the event for getting an odd number while rolling a fair die. So the favorable outcomes will be what? It will be 1, 3, and 5. So NE, number of favorable outcomes, is 3. Now coming to the probability formula. Now I know everybody knows the probability formula, but I will tell you a very important concept for this. Just P, now let's write the formula first. PE is equal to NE by NS. Here E is favorable outcomes, as I just discussed, number of favorable outcomes, and this is number of sample space. Now what is the important concept? The concept is this formula only and only works when the events are equally likely, when the outcomes are equally likely, okay? This is the important concept. Only when the outcomes are equally likely, we use this formula. Now coming to the next topic, which is mutually exclusive events. What is mutually exclusive events? Two events are mutually exclusive if they cannot happen together. Cannot happen together. For example, when we roll a die, do we get two numbers at once? Like, we cannot get 3 or 5 at once. All right. So, yeah, we can see this like in mathematical term, like probability for getting A intersection. Just wait a minute. Yes, for A intersection B is 0. Why 0? 0 in probability means impossible event. Yes. Now coming to the next topic, which is exhaustive events. What is exhaustive events? A set of events is said to be exhaustive if it includes all possible outcomes of the experiment. So you get it? Events should include all possible outcomes. Right? For example, again, we'll take the example of rolling a die. And we take A to be getting 1 or 2, B to be 3 or 4, C to be 5 or 6. Then together, A, B, C, this will be exhaustive. Why do I say this is to be exhaustive? Because they cover everything from 1 to 6. Right? Now coming to the next topic, occurrence of an event. What is occurrence of an event? An event is said to have occurred if the outcome of the experiment lies in that event. So outcome should lie in the event. We can understand this nicely by saying event E to be 2, 4, and 6. And outcome, let's say 4. Do we see the outcome in the event? Yes, we do. Then has the event occurred? Of course, the event has occurred. Now coming to the next topic, complement of an event. The complement of an event is everything that's not in that event. Because we know the meaning of complement, right? Whatever is not in the event is the complement of that event. Now, again, we'll take the example of rolling a die. If event A is 1, 2, and 3, then what should be the complement of event A? It should be 4, 5, and 6 because it is not there in event A. For the formula, what is the formula? P means probability. Probability of A complement is 1 minus probability of event A. Now we'll come to a very interesting topic. Why probability lies between 0 and 1? Why is this range? Why do we take this range? Where 0 is impossible and 1 is certain that the situation will happen, right? Now, why do we say this? Because probability is a ratio. Ratio, what is the ratio? Ne by ns, which cannot be less than 0 or more than 1. Am I correct? It cannot be less than 0, this probability of any event, and more than 1. It lies in between. Converse is false in infinite sample spaces. Why do I say so? If a number is between 0 and 1, it's a probability. This is the converse, right? But it is not always true. Not always true when the situation is infinite sample space. Sometimes a number like 0.3 may not represent a real probability, especially when the sample space is infinite, right? Because it is not a real world situation. Any This is very important in advanced statistics. Even though a number is between 0 and 1, it must come from a valid experiment and valid event. So the converse is not always true. This is the ending of today's lecture, because these were the basic terms which we understood today. Now, again, I'll post a video today only regarding, I'll just solve 2-3 questions on these topics. Okay. So yeah, take care. Bye bye. We'll see you on the next video.